So, one important question. The diameter of a hollow metallic sphere is 60 centimeter and the sphere carries charge of 500 microcoulomb. Then find the electric field intensity at a distance of 100 centimeter from the center of the sphere and at the surface of the sphere. Suppose this is a hollow metallic sphere. This is point P and this is point P prime. Okay, we will calculate the electric field intensity at the surface of the sphere and at a distance 100 centimeter from the center of the sphere. The electric field due to a charged sphere has spherical symmetry. Therefore, behaves far here r equal to 100 centimeter equal to 1 meter, q equal to therefore E equal to q equal to 500 10 to the minus 6 divided by equal to 4.5 and the 6. Okay. Then question number 2. At the surface of the sphere, at the diameter of the hollow sphere is 60 centimeter, so the radius of the hollow sphere is 30 centimeter. R equal to OP prime equal to 30 centimeter Q equal to 500 microcoulomb equal to 500 into, therefore E equal to the 9 into equal to 7. So the question asked, calculate the electric field intensity at a distance of 100 centimeter from the center of the sphere. So at a distance of 100 centimeter, the electric field intensity is found to be 4.5 into 10 to the 6 Newton per Coulomb. And question number 2, at the surface of the sphere, and at the surface of the sphere, the electric field intensity is found to be 5 into 10 to the 7 Newton per Coulomb. Another question, two equivalent opposite charges of magnitude 2 × 10⁻⁷ Coulomb are placed 15 centimeter apart. Find the magnitude of electric field intensity at a point midway between the charges. Say what force would act on a proton placed there. So this is point A and this is point B. Two into 10⁻⁷ Coulomb, and this is equal to So the question asked, calculate the electric field intensity at this point, at the center of the charge, at the midway between these 2 point charges. We will calculate the electric field intensity at point N. So this is the condition of the problem. This is the condition of this problem. Here M is the midpoint. That is AM okay. So electric field intensity at point M due to this charge 2 × 10⁻⁷ Coulomb. So electric field intensity at point M due to charge 2 into is given by E1 equal to 1 by 4 percent 0 q by r square, q equal to 2 into 10 to the minus 7 by r equal to okay. So am equal to 7.5 centimeter or 0.075 meter. So r square. So this is equal to 0.2. As this is positive charge, so the direction of electric field is towards repulsive force. Okay, towards am, along am. Okay. Similarly, okay. So since the charge particle is a negative charge particle, so there is will be attractive field. So that is towards MB. The direction of electric field, the direction of E2 is along MB, along MB. Okay. So since E1 and E2 are along the same direction, therefore E1 is along AM and E2 is along MB. That is E1 and E2 are along the same direction. Therefore, resultant electric field intensity at point M, midway between these two charges. Therefore, resultant electric field intensity at point M is given by E equal to E1 plus E2. Okay, so this is equal to plus along MB, along MB. Okay. So another question asked, what force would act on a proton placed there? If at point M a proton is placed, then what is the force acting on the proton? Force acting on a proton placed at M is given by force acting on a charged particle in a uniform electric field is F equal to QE. F equal to Q into E. So Q equal to 1.6 10 to the minus 19 coulomb. Charge of proton. E equal to 0.64 into 10 to the power 6. Okay. So this is equal to 1.024 into 10 to the power minus 13 Newton along MB. Okay. So if a proton is placed at point M, then force acting on the proton is given by 1.024 to 10 to the power minus 13. This is the answer. Okay.